Hi everyone, I'm Won Lee. I'd like to continue estimation for the difference between two independent populations. It is a little complicated, but you need to understand this kind of material. Okay, so I'd like to continue. All right, we have two independent populations, and each mean mu x, mu y. Then we'd like to know what is the difference in their means mu x minus mu y. Okay, mu x minus mu y. Best estimator is sample mean from population 1 minus sample mean of population 2. So best estimator is x bar minus y bar, and we have to know its distribution. That distribution follows like this. We standardize it, and we have equation as for one population case. So we get this confidence interval. But I told you that confidence interval cannot be used because we do not know sigma square. We have to sigma square for population 1 and population 2, but those two variances are equal case is not equal case. Okay, so now when population variances are equal, then we don't need any subscript here, sigma square. So we have to estimate sigma square from samples, okay? The samples used to estimate sigma square will be both of them. Both of them means from here, x1 up to xn1, from here, x1, y1, y2, yn2, into many, and here n1 many. So how to do it? Just mix them. Pool it. The estimate of a sigma square obtained by combining these samples is called pooled variance estimator. So this is a pool. x1, xn1, y1, yn2. They are pooled and get one estimator. Okay, there is a pooled variance estimator S square. Subscript is a pooled, shortly SP square. Then how to do it? Xi axis what deviation squared, y deviation squared. Sum of them and divided by what degrees of freedom. How many degrees of freedom here? From here, degrees of freedom is n1 minus 1. From here, degrees of freedom n2 minus 1. And x and y are independent, right? That's why degrees of freedom here, n1 plus n2 minus 2. Understand that? This is an important concept because you will study this kind of thing in analysis of variance. Anyway, now substituting sp square to g, where is g? Over there. I think, oh, there, here. Okay, g is x bar minus y bar minus mu x minus mu y divided by square root sigma x square n1 sigma y square divided by n2. This is g. So those two variances are equal sigma square. This one comes to here, okay, and we use pooled variance estimator instead of a sigma square. Then we obtain what? T statistic. T, it should be changed to T like this. Sorry, this is, oh, this is not square, just a sigma, right? So this T has T distribution with degrees of freedom n1 plus n2 minus 2. Understand that? As dealing with a single population. Therefore, 1 minus alpha 100% confidence interval for mu x minus mu y is same thing. This one, lower limit, upper limit. And we have to use degrees of freedom T, degrees of freedom n1 plus n2 minus 2. Okay? I hope you understand this part easily. And how about unequal case. In this case, we have to estimate the separately. Sigma x square, estimate this way, sigma y square this way. No way, right? That is, we use the estimator this too. Hence, 1 minus alpha 100% confidence interval for mu x minus mu y, that should be substituted sigma x square and sigma y square. Okay? So a little difficult, complicated expression, and degrees of freedom for this case, alpha over 2, we have to get t alpha over 2 value. It has some degrees of freedom. Degrees of freedom is very, very complicated. You don't have to worry about, you don't have to memorize it. We may use nearest integer value of this one. This calculated this way. Into this calculation, it can be only calculated by what? Computer. So we cannot solve this problem in our hands. We have to use computer. Understand that? Anyway, there are two cases. Two variances are equal. Two variances are not equal case. But we have to use computer in order to solve this problem. I just add one more page, Python coding for this example. This is example data, two independent population, sample size are equal 5, and you may follow this Python coding, okay? I cannot explain this kind of a thing. I mean, Python coding here. So if you know Python coding, then you can follow. Otherwise, I have no idea. I'm sorry. Okay, this is it today. Thank you. Bye.